Alright guys, we're going to go through the very last problem on the sheet. So if we're at all confused about something, this problem probably has it in it. Before I start the problem though, I want to make sure that we are all clear on, make sure I'm copying this right, my eyes, it's kind of small for my eyes. I want to make sure that we're all clear on a couple of fundamentals. First of all, because we're not going to be using a calculator for this kind of stuff. If we have 4 to the negative second, what does that mean?
1 over 8.
No, it is not 1 over 8.
1 over 16. My
It
apologies,
is
guys.
1 over 4 squared, which is 1/16. And then, if we have 4 to the 3 halves, we're going to think of that as the square root of 4 cubed. Right? So that would be 8. And then if we put them together, we take care of the negative first. So 1 over 27 to the 2/3. And then we interpret the 2/3 as a cube root squared. So 1 over the cube root of 27 squared over 9. All right? That is no calculator. You need to be able to do those basic things without a calculator. Now, this one, obviously we're not going to use a calculator on this one either, but it is crazy. So Jack, you can actually do lots of things to start this problem. There isn't like an order of operations or anything. What did you do first, or what would you like to do?
I did the bottom parentheses.
So you just,
Yeah.
I hate to use the word distribute, but you know what I mean,
Yeah.
right? Okay, so that became x to the what? What do I do with these?
You multiply them.
Multiply them. Yep, that's a multiply. So that's going to be negative 5 halves.
Yeah.
And then y to the negative 9 halves. All right, then what did you do? That looks good so far.
Then I flipped like
Move the negative
move
things
the
around.
negatives.
So I like to do that myself. I would probably do that. So the y to the 1/3 staying up, the y squared is coming down. These are both going up. And of course, when I move them, their exponents become positive. Okay.
And then I distributed the, then I got rid of I combined the y to 9 halves and the y to 1.
You could do either thing, but I like that idea better. Cleaning this up in here first. So what's going to happen, there's nothing to do with the x's because they're the only ones. But what are you going to do with the 1/3 and the 9 halves?
You add them.
You're going to add them, and then what are you going to do with the 2?
You're subtract it.
Okay, so I have 1/3 plus 9 halves minus 2 over 1. Those are all my y exponents. So I'll make them all into 6s. So it looks like I'm going to have y to the, what is that? 17 sixths. And it's still to the 3 halves. So what do I end up with? X to the 15 fourths. And y to the 17 fourths. Is that okay?
Yeah.
Okay. Alright. Anybody else have one that you want to talk about? What?
Don't you move the 4 up so it's a 4 root x of 15 y 17?
You write it as a radical?
Or like those where you change.
Yeah, like the 4th root
You
of x.
can write it as a radical, but are you going to be able to simplify it? I mean, what's that going to help? That's what I guess my point is, what's that going to
Well,
help?
since there's 15 x's and 17 dies, can't you pull out a couple of them?
You absolutely can, again, have radical left.
Yeah.
Yeah, so actually, the general rule of thumb is, unless you're told otherwise, if the problem is presented with exponents, you answer with exponents. If it's presented as a radical, you answer with the radical. Now, is there anything in these directions that say my answer's, no, I'm just gonna leave it just like that.
But for the fraction exponents, is that okay if it doesn't say anything? You can have a fraction exponent.
Oh, yeah,
Okay.
there's nothing wrong with fractional exponents. The only exponents we don't like are negatives, and we also don't necessarily like these guys if they're in the denominator, because think about what that means. What does that mean? I have a radical in the denominator, and I don't like those, but these guys are fine, they're in the numerator, so it doesn't matter.
Okay.
Now, I'm not saying you couldn't rewrite that in a radical form. I'm saying it accomplishes nothing, so I'm not going to do it. This one can be simplified completely. If this had been 4 to the 6/7, I would leave it 4 to the 6/7.
Number one on 3.9. I know it's simple, I just want.
So, where you're taking a to the 1/2, b to the 1/2, to the negative first, well, that's just gonna become a to the negative 1/2, b to the negative 1/2, which is 1 over a to the 1/2, b to the 1/2. Would you agree with that? Now, there are no directions telling me I can't have fractional exponents in the denominator. As a matter of good form, in Algebra 2, I would definitely get rid of those. But in this course, they allow us to leave things like 1 over root 2. So I'm assuming it's okay to leave it like that. All right, anything else?
Can you do number 4 from the third section?
Yep. All right, one more here, and then we're gonna get our notes out, and we're gonna start practicing a couple of things here. So, the one that says 2x to the 1/2 y to the 1/3, and 2x to the 4/3. Am I on the right problem, Marion?
Yeah.
All right, make sure I copied it right. Okay, are those 2's really just both hanging out there? Can I just get rid of those? Okay, and then what did you do next?
I like most of the lines out and
So this guy went to the top because we don't like negative exponents. Now, some of you are sitting back there saying, I didn't do that. It's okay. There's different strategies we can use. I like her strategy. I like that, Marianne. Okay, then what did you do?
I combined the y's and also I moved my x like that.
Okay, so these guys are going to get added, right?
Yeah.
So that's gonna give me y to the, what is that, 25, 12? Okay, and then what did you do?
I subtract 1/2 from 4/3.
So common denominator, and that gave you, x to the negative 5/6, is that right?
Yeah, I used it.
And then this is going to the bottom.
Yeah.
So y to the 25/12 over x to the 5/6. Is that okay?
Yeah.
All right. Let's get our notes out, 2.4 notes.
So we can leave an exponent in the denominator as long as it's
And then I tried to get rid of the
I was gonna say, I don't know, do I have one?
Okay, so, at the top of the notes, again, he does this in textbook form, it's awesome. At the top are your properties of exponents that you already should know. If you don't, there they are with a few examples. You can get those simplified in your head. Let's look at example 1. Horizontal transformations. So as you can see, in all the problems there in example 1, he has messed with the x's. Anytime you mess with your x's, you're doing something horizontally, right? So look at A. What is happening? The original graph is y equals 4 to the x. You know what that looks like. It's an exponential growth problem, right? That's what it looks like. Now, what happens when you add 2 to that exponent? Think about that for a second. Give and leave the keys and go move your car. Okay. So what does that do? That x plus 2 exponent, what does that mean?
What does it do horizontally?
Is it, yeah, what's it do horizontally?
Is it the wired?
No,
Oh, it brings the.
it moves it
2 to the left.
2 to the left. Guys, the rules haven't changed. When you add or subtract, you're moving. It's called a translation. You're moving your thing. And when you add 2 to your x, you're going left 2. So basically, we added 2 right there. So basically, we're just gonna take this picture and we're gonna shift it 2 to the left. So this point was 0, 1. Where's that point gonna be? Negative 2, 1. Right? Everything is shifting 2 to the left. You were right. Now, what about the second one?
Oh, flip.
Does it
Yeah,
triple?
make it wider.
It can be, we'll talk about that, it can be a vertical change, but the way it's written right now, it's horizontal. Let's talk about that for a second. What does multiplying x by 3 do? Divides the width by 3. So it's a third as wide. It's a third as wide. Remember? Remember all that transformation stuff we did, guys? You guys actually had a handle on that and did pretty well with it. All right, what happens with H? Or C,
Doubling.
problem C, function H.
It's doubling, right?
It makes it
Wide.
twice as wide. Twice as wide. And what does D do, function K?
Move it left.
Move it right.
Right one. That one goes right one. Right one. Right one. Okay. Let's look at the next problem and figure out what in the heck those directions mean. Each of the following exponential functions has a horizontal translation. What is the horizontal translation of this function? Left 3, right? It's 2 to the x, move left 3. Now, what he's claiming is, I can rewrite this with a vertical dilation, in other words, a vertical transformation, and no horizontal transformation. In other words, this problem can be rewritten as a standard exponential. This is your vertical dilation. This is your multiplier. Okay? Anybody have a thought on how you can do that? It's actually so easy. Would you agree that this is the same as 2 to the x times 2 to the third? Think about that.
Yeah.
Yeah, because don't we add these exponents? And of course, 2 to the third is just, I'm gonna pretend I didn't hear that. It's on video, I hope it was quiet enough. 2 to the third is 8. So times 2 to the x, there it is. So this equation, if you type this in on your calculator and this in on your calculator, guess what? They would be right on top of each other. They're the same picture. Okay, what do you think about this next one? What do you think about this one?
3 to the x over 3 squared.
This is the same as 3 to the x times 3 to the negative second. And of course, what's 3 to the negative second? 1/9. So this is 1/9 times 3 to the x.
3x over 2.
Normally we would write it a times b to the x, but it would be the same as 3 to the x over 9. All right, and try the last one on your own. See what you can come up with for that last one. Ava, have you ever done? Okay, what'd you come up with? Ava says it's 36 times 3 to the x. What do the rest of you think?
I concur.
Is she right?
I think so.
Yep, she sure is. Because this is 3 to the x times 3 squared, and that's 9 times 4. Beautiful, Ava. All right, flip it over. You and your partner come up with, these are multiple choice. 2 of them. First one's easy, second one's not quite so easy.
Alright, I'll take the second.
See what you come up with. There's one right answer. One right answer.
We got, no, 81. Yeah, you're right.
That's nice.
Think about it like this. We break it apart.
So we're on example 3, which means basically that was just break it apart.
Hey, are you men back there talking about these two problems?
Yes.
No, you're not.
Like that.
Well,
I need you to stay focused. All right. So, Christopher, what did you guys get for example 3? D? I think D is right. Does anybody want to argue that? Isabella, you got it? Okay. Are we good with D? All right. How about example 4? Nick, what did you guys get for 4?
C.
C? What do the rest of you think? Range is right?
You like, so you can break that.
Oh, yeah. Just changing it. Yeah.
I'm gonna check Mick's idea. He thinks it's C. I'm gonna rewrite C, instead of x over 2, I'm gonna write 1/2 x. I like it, it looks better to me that way. Tell me about 16 to the 1/2. What is 16 to the 1/2? 4. I think Mick's right. I think he is right. Alright? In a few minutes, we're gonna do that exponential matchup, but right now I want you to go to the back side of that paper. Go to the back side, please. We're gonna come back and you're gonna have a chance to work on that little exponential matchup thing. But I wanna run through these problems, first of all. So we have this G function that looks like this. What they call the parent function is y equals 2 to the x, which you know looks like this. I keep saying this, I hope you know this is what it looks like. It's exponential growth. It has a horizontal asymptote at y equals 0. Now, what has happened in the problem? We've taken this picture and what have we done to it? Left 3 and,
Wait, left 3?
or left 1. Left 1 and up 6. Now, when you lift this up 6, guess what? That asymptote that was at 0 is now going up to 6. So now you're going to have your horizontal asymptote is at 6. Okay? And your curve is still increasing, but it's up there now. So, what is the domain of this function right here? What is the domain of the G function? Negative infinity to infinity. Shifting it around, lifting it up has not changed its horizontalness. It's still going forever in both directions. What about the range though?
6 to infinity.
Now the range is 6 to infinity, and make sure that 6 is open because it's the asymptote. What is the y-intercept?
8.
How did you get 8? Somebody said 8 and you're right. How did you get 8?
You plug 0 into the x.
Exactly. Guys, it doesn't matter how hideous your equation looks. How do you find a y-intercept? You let x be 0. It doesn't matter what kind of an equation it is. When we do, in Unit 3 is all about trigonometry. When we start doing the trigonometry, how do we find an x-intercept? Or excuse me, a y-intercept? We let x be 0. It doesn't matter. All right. How about the end behaviors? Now, I kind of rough sketched my picture here, but what is the limit as we approach positive infinity? In other words, what's the limit on the right side of your picture?
Positive infinity.
Infinity. How about on the left side of your picture?
6 from the top.
6 from the top? Perfect. Now, number 2 is kind of a fascinating problem. They have drawn a curve for you, and the equation is a to the x plus c. It's just like this one, 2 to the x plus 6, a to the x plus c. And they want to know which statement is not guaranteed. So looking at the picture, looking at the equation format, what do you
Let's say
think about
B.
A? Is A guaranteed?
Yeah.
How do we know A is guaranteed?
Because if
Maybe
we look
left
at the
side.
graph, the
Look at the
intercept
graph.
is- The
Maybe
intercept
asymptote.
is,
0. When y is 0.
We look at the graph,
the
the horizontal asymptote's below the y or x-axis, right? Perfect. All right. What about C?
It's decay.
That one's right because the problem is clearly a decay situation, which automatically means your base is between 0 and 1. What about D?
That's true.
It's true.
As it goes to the right, aren't you getting closer to your asymptote?
Yeah.
So the one that isn't guaranteed is B. What's going on there? Could it be true? Could A and C add up to a positive number? Yeah. A could be, I don't know, 2/3, and C could be negative 1/3. But it could be the other way around also. So, yeah, B is the one. All right, you already practiced this, but rewrite this equation, rewrite that equation as this form. Okay, so we just talked about how to do that. Do that real quick, you should be able to. Shout it out if you have a plan. 1/2 times 2 to the x. Yep. Because this is 2 to the x times 2 to the negative first. And 2 to the negative first is 1/2. And then finally, number 4, you want an exponential function. You'll write your own. It has to be increasing and concave down. Increasing and concave down. Now, remember, you have 2 kinds of exponentials. You have this kind, which we call growth, and you have this kind, which we call decay. But you can also put a negative in front of them and tip them upside down. So that one would do that, and this one would do this. So really, those are your only 4 shapes. So do I have one up here that is increasing and concave down? Is that right here? Who is the flip of this one? So when I write my equation, it has to have a negative, something, I'll just say -2, it doesn't matter, you write my equation. And then my base has to be something like that. So there's an example. There would be lots of them. You just need this number to be negative and this number to be between 0 and 1. Everybody good with that? Okay. Here's what we're gonna do. I'm gonna hand back some paper, but this is what you're gonna be doing. Turn the page back over and go back to your exponential matchup page. In the interest of saving paper, please do not write on this, okay? Do not write on this. But what every group is gonna get some equations, and then 2 pages of graphs, and you're gonna match them up. And you're gonna match them up on that paper right there, okay? Please don't write on these. Unfortunately, in the other class, there were some kids who wrote on them, so try to ignore what they wrote.
Whoa, whoa. It is the season of giving. The camera can hear you.
That's right.
I'm gonna show your mom.
Are we all working together?
Hey guys, incredible group here.
Given, are you? She's a girl. I don't talk to girls.
Oh, we can tell, baby.
Given the queen. We're gonna go
No.
crazy. Wow.
She doesn't want me here.
I was looking in a duo. She said it was fine.
Trio.
Yeah.
She said that you can help me come over here.
But she said it was fine.
Go work with me.
There is not.
You can put like Miss Ford. I already did it. She brushed me off.
Here's what's gonna happen, guys. I'm just gonna work.
We can be
Guys, stop. Guys, let's work together. Can you, I did not make my choice. Can you stop? Please work. Stop. Please stop. Come over here. We had a trio going, Greg, and you ruined
I'm
it.
so sad. I'm sorry. Maybe you just shouldn't have come back to moving your car. Why was it supposed to move your car?
Can you sit down or leave?
Wow.
Does everybody have one page of equations and 2 pages of graphs?